Hi, this is Mark Kemper with EMS, and today we're at Elevation DF in Tampa, Florida, one of our customers, and what we're going to do today is we're going to 3D scan this race car chassis so that we can duplicate it using a CNC bender and CNC machine. All right, so let's get started and talk about, well, why would we want to do this? Why would we want to 3D scan this? Well, this tube chassis here is custom made. It was custom built to fit into this car, but now we want to replicate it. So, for example, we want to make duplicates either to sell or maybe we've got multiple cars. Well, instead of having to try to bend everything by hand and cut everything by hand every time, what we're going to do is we're going to 3D scan it, and then we're going to take it into Geomagic Design X and use some of the tools in there specific to tube chassis design or pipe design, and we're going to turn it all into CAD, turn it into different pieces that then we can export into a file format that a CNC bender and a CNC machine could then use to replicate. And the idea here is we'll duplicate it and we'll do it very precisely every time, so we can build all of the pieces and then put them in the car and everything fits up perfectly. So that's what we're going to try to do today, and we're going to start with the 3D scanning, and then later we'll go into Design X and show some of the design capabilities.
All right, so to get started with the actual scanning, we're going to want to put some targets around the vehicle. And for this, we're going to use this SpeedTarget system, which is basically targets on clear tape that has an adhesive on it. And even though we're going to be using the Creaform GoSCAN Spark, which doesn't necessarily require targets, when you have a lot of gaps in between things, you really need a way to be able to move around and track everything. And the way the GoSCAN works is it tracks by geometry. But again, if you've got large voids, which we have kind of on this tube frame, you're really going to want to have something that can help you. And by applying those targets, it basically gives you a path to kind of lock everything down. So we'll put some SpeedTarget tape up in some different spots here, and then we can get started with the scanning. All right, so now we're ready to actually start the scanning. We're using the GoSCAN Spark. And the reason Elevation DF chose this scanner is it's extremely fast, it's portable, it's easy to use, and it doesn't require targets in most situations. Now, for a lot of this vehicle we're scanning, we don't require the targets. But then we have large gaps in the tube frame where there's basically no geometry whatsoever. So the nice thing about the GoSCAN Spark is if there's geometry in the area, it'll lock onto it and use that to track. And if there's not, we can put those targets like we did, the SpeedTarget tape. And it allows us to move around and align to both targets and geometry. So it gives it a lot of flexibility. And if you want to learn more about the GoSCAN Spark, in the description below are links to detailed demos that go into a lot of the features. But basically what we're doing here is we're just moving around and trying to capture the whole tube frame and then some of the areas it mounts on the vehicle. And it's all line of sight, so we're just going to keep moving around as we need to scan everything and try to pick up as much as we can. So one nice thing about when you're working with tube stuff or pipes, you don't need the whole thing. You don't have to get 360 degrees around. As long as you get about 30% of the diameter, that will give us enough information for the pipe wizard. So we'll just, again, keep moving around and at least try to get as much as we can, get the key mount points, and then get all the tube chassis, at least a third of it. So what's, again, nice is those SpeedTarget tape allows us to move around easily without losing track of where the scanner is in 3D space. Next, we lowered the vehicle so we can start getting more towards the front and then get up higher on the actual kind of roll bar, roll cage. And we just keep moving around. You can't overscan it. You can certainly scan over the same areas. It doesn't hurt. But we're just moving around and transitioning over to the front of the vehicle and the side. And, if at any point we need to add additional targets, whether it's the normal targets or the SpeedTarget system, we can do that. You can stop scanning if you're having trouble having it lock onto the geometry and simply apply more targets. And you can mix speed target with normal targets. But again, the speed target works great on parts like this because of the big open spaces between everything. And then we just continue scanning and it'll find those targets and you can continue on. But having those extra targets spanned across there really helps lock it on. And again, you just keep going over the areas. It's instantaneous. You see on the computer screen exactly where you're scanning. When you see green, that's good. That's the proper distance away from the part. If you see red or blue, you're either too close or too far. But you just keep going around until you have everything that you need. It's all line of sight. And the more perpendicular you are to the surface you're scanning, the better. You're just going to get better quality data. But then we're going to take all of the scan data into a reverse engineering product, and there's many. We're going to show DesignX, which has some really nice pipe wizard tools. But the idea there is we're going to take the scan data in, we're going to turn this roll cage chassis system into a CAD model for downstream applications like CNC bending, a CNC machine, a water jet cutter, or a CNC laser cutter, whatever it may be. You need 3D CAD in it to be able to work with those systems. So we're going to basically convert this scan data into CAD data, and we'll show that next. All right, so here we are in DesignX. Now we're going to focus on a few commands here in DesignX. If you really want to learn a lot more about DesignX and really more of the fundamentals, we've got some other great videos on our website. But basically, here is the 3D scan data from everything we captured. And what I've already done is I've separated out the roll cage from the body. And then I also separated out the mounting areas, or mounting plates, I'm calling them, you see here. Because what I really want is the roll cage itself, or the chassis, whatever you want to call it. I want that separated so I can start turning it into CAD. So you can see our scan data looks pretty good. It's not perfect. Obviously, there was areas that we just couldn't get at. So, for example, up here where this roll cage goes up against the A-pillar, there was just no way to get it. But what's nice about this command is we don't need data everywhere. As long as we have about a quarter to a third of the pipe or the tube frame, as you see here, we'll be good to go. So the first thing I did was I just separated that scan data. Like I said, we've got the chassis itself. We separated out the mount areas, and then that left just the scan data of the vehicle, which we really don't need. It's good for reference. We'll want it in here, but we really don't need it. All right, now the next step, what I did to get ready here is I broke the chassis here up into sections by using region groups. And what you basically do is you just color code the area. So I've already done it. I'm just going to turn it on and show it to you. And what I've done is I have created these regions, and it just color codes the scan data. And what that does is basically gives me these segments or these regions that I can then actually create the CAD through. So I don't have to physically break up the model, to get the individual pieces. So for example, even though this is all welded together, we need to, create each one individually, because that's how they're going to be manufactured and then all welded up. So, for example, here you can see these are all just regions, and we've got videos that go into more detail, but you basically, on regions and other things, basically you just, here, I'll create one over here just to kind of show. So what you do is you would just window in an area. So for example, I want to get as close to this joint as possible, but not actually at the joint, because if you include the joint, you're going to have problems. So you see how I've selected that area, and then I'll just go under regions. In this case, I'll insert it. And all it's going to do is take that selected data and color code it for us. And you'll see why here in a minute. Okay, so you can insert them, split them, merge them. All you're doing is color coding the scan data, and then you'll be able to reference it using different commands later. So again, you see that's color coded here. Now, why did I not do that over there already? Well, this this chassis should be symmetrical, and the reality is it isn't, or probably won't be, but we're going to make it symmetrical. We're going to assume that the car we're going to put this in and, is symmetrical. So what we've created is a mirror plane, and that's right here, and everything we build we will mirror over. Okay, so you'll see that in a little bit, but that's why I didn't put the region groups over on some of these pieces. And you can see I've only driven some of these region groups past the halfway point. Okay, so let's get started, and hopefully this will make a lot more sense. So the first thing I'm going to do is pick one of these areas to get started. Now, it doesn't necessarily matter which one, but I'm going to start with one of these large ones. And we're going to go under the home menu, and this drop down here, this one here has some different wizards. We're going to be using the pipe wizard. Now, there's two ways you can access it. You can use this auto search where you click and it starts finding areas for you. And that's great if you're doing like big buildings where you've got lots of pipes and they're broken up into a lot of sections, or they're going in many different directions. But for this kind of work, I prefer to make the region groups ahead of time. It just lets me control exactly where I want it ahead of time. So I just click on the region group. You can see it selects it there. Now I can either do auto radius or I can drive the radius. I know the radius is 0.75 inches. And so I'm going to put that in. So it's always going to be that instead of it trying to figure it out. Now, the first thing it does is it gives us a couple views, and you kind of get a highlight here of what the pipe would look like. And essentially what we're doing is fitting a solid model through here by creating a section. So creating a diameter, a circle, and then finding the center line all the way down that scan data, that region. Okay. And I'm going to click cap ends because I want to make this a solid body, not a surface. You can either do freeform or use lines and arcs when possible. Now, I find when I use lines and arcs where possible, or when possible, sometimes it works, sometimes it doesn't. It's trying to break it up, make arcs and straight segments where it can, but depending on the scan data and stuff, it can be a little bit more of a challenge. We'll talk about that some more later. Now, the other thing I'm going to do, because I have pretty good scan data here and I want to follow it pretty well, but you can see by default, it makes a ton of points along that line, that sweep line that it follows. And we really don't need that. So I'm going to click build curves. And for example, maybe on this one, I'm going to go 25, and we're going to pick that curve and then hit OK. And that's just going to reduce the amount of points for us. We don't need that many. You can always do this later, but you just get a smoother curve by not having so many points. It tends to smooth it out. And maybe 25, maybe even don't even need that much. But you can actually deform the curve right here and pull it and tug it. I tend not to do that. So let's go ahead and hit OK. And you're going to see what we end up with. So here's our scan data. And if we hide it, there is our first solid body. So you can see what we get. Now, what it's actually done underneath is created a 3D sketch. So if we hide the solid body, so it's put in that 0.7 radius, 0.75 radius. It's found the center of that, that scan data. And you can see I've respaced it to 25 points, and it's driven a center line down there. Okay. So that's essentially what it's doing. So if you actually look in your tree now, it's actually a sweep. So the pipe wizard just kind of automates it. Could I cut a section through the scan data, create the circle with the diameter, and then try to find the center line all the way through this pipe? Yes, but it would take a lot longer. But I can still edit it, and you're going to see that here shortly. Okay. So again, there's our first solid body. Now, one thing to point out is because my region group ended right here, I've obviously avoided this area here, and I've done that on purpose for a couple reasons. One is, you can see it's fit into the pipe. Sometimes you'll have a lot of weld in here. You don't really want to go up in here because the sweep or the pipe wizard's going to get confused. So I always do it just back from the intersection, right? So that's why you see that. Now we're going to make it all intersect here in a minute, but I just want to point that out. If you notice all my region groups, they kind of stay away from the actual intersections, okay? So the next thing we're going to do is let's go ahead and do this next one, which will be this one here. And you can see I've got a region group that goes up. Now, theoretically, I could go just past the center line, but we've got this support coming up into this area here. So I've gone beyond it. And again, we're going to mirror some of this stuff over. But let me go ahead and run the pipe wizard. And again, we're going to pick the region group. We're going to type in the value of 0.75. We're going to go to the next screen, and it's going to calculate that center and drive that circle. And I'm going to hit cap ends. Now, this time when I hit cap ends, it's going to ask if I want to merge because I've already got one solid body there, and I don't want to do that. By default, it turns it on. We'll do the rebuild curve again. And, for this one, maybe we want a few more points. This is kind of a trial and error thing. You can play with this, okay, to get what you want. And we'll hit OK. Okay. So now if we again hide our mesh, you can see now we've got this one here. And again, I've only gone that far because I need to go just at least enough to get up to here if I want to add that in before I mirror it over. You'll see here when we get to that. So there's what we have so far. Now, obviously, again, they don't intersect right here. And let's go and edit one of these first, and I'm going to show you a couple things. So if we wanted to edit this path, for example, we could come to, let's go back to our first 3D sketch. If we double click on it, we go into 3D sketch mode. And, I could grab a point on there and deform it. And then obviously our pipe, would follow that. Okay. So obviously I don't want to do that, but it does allow me to make some changes because, this is only as good as the input. So, this one you can see it goes up and then kind of angles in by design. But this one here, I might want to make the assumption that this should all be sitting in a plane. And maybe it's not quite, right? Because again, we're trying to follow a 3D shape. So I want to show you something you can do. And the first thing, though, is let's connect these. So right now they don't connect. So what can I do to make them connect? Because we want them to connect up properly, right? They need to mate. So if we go, let's turn off our solid bodies. And now I'd like to I'd like to connect this to that one. Now watch what happens when I double click this. Well, when I double click and go in the edit mode, you can see the other one disappears. And that's because in the history tree, that second one is here. It was created afterwards. So because I'm going back in time and trying to edit that sketch, the other one isn't there. So one trick you can do is just grab that sketch, make a copy of it. So I just copy and then paste. And then what I'm going to do is just move it back in time, so to speak. So now when I double click this, so essentially there's two there. I don't really care. But now I can grab this point and I can connect it right to that curve. And, I'm going to look at it and make sure it's lined up and looks pretty good. And now when I exit out, being history tree modeling, you can see what it's done. It's connected it right to that center line, which will get us right to that pipe. Okay. Now there's some other ways I can do this as well. I'll show that later, but you can see overall that looks pretty good. Now, the next thing I'm going to want to do, because if we're going to CNC cut these probably with a laser or plasma cutter or, even a CNC mill, if we're going to make these two fit together, one of them is going to have a cutout for the diameter. And let's say we're going to, obviously it would make sense for this one. Well, we need to know where that, what that shape looks like. Obviously it's not going to be that straight shape. So what I typically do for this stuff, there's a couple ways you can do this, but what I found works well is I'm going to go in here and I'm going to do a surface offset, and I'm going to pick this tube here, and I'm going to offset it a little bit, 10, 20 thou, something like that, totally up to you, and I'm going to create a surface, okay? So now I have this surface that's just a little bit thicker than the tube itself, and what I'm going to do now is use the cut command. I'm going to use this as my tool entity, this is my target, and then it's going to ask me which side I want to keep, and that's going to be here, okay? Now, so you can see what we get. Let's go ahead and hide our surface for a minute. Why did I put that gap in there? Two reasons. One is I'm going to get a better trim. Otherwise, it's really tough to get these to line up perfectly tangent when you're in 3D space, so you just get a better trim. And secondly, it gives us a little bit of a gap because these are going to be, hand fitted together and then welded up. And if you had everything really, really tight, it can just cause problems when you try to assemble it. So you give yourself a little bit. It's all going to be welded anyway, so structurally it's going to be just fine, and that gives you just a little bit of a gap in that area, okay? But that's how you make the joint. So what we end up with is, and it's just a solid body. Could we thin it out for the actual pipe thickness? You could, but you don't need to, right? What we end up with is this solid body that has the exact shape that then they can CNC program for typically a laser cutter or a CNC mill to cut out that shape. And then, of course, the center line, and we can output the center line, or usually when you take it in your CAM software, they can drive that center line. That center line is going to be important for the CNC bender. And then this profile here is going to be important for, however you're going to cut this, whether it's a wire cut, CNC, plasma cut, water jet, whatever you're going to use. You've got that profile right there, okay? So let's bring those back. So there is our first step. Now, the other thing you can do is you can edit this. You saw me pull the center line out. But let's say I know this is supposed to be on a plane, and maybe it's not quite. So let's go back to that 3D sketch for a minute. Oops, wrong one. Exit out of there. That'll be this one here. So there's our 3D sketch, and we actually have two of them. Let's turn one of them off, okay? But if we look at it, maybe it's not quite in a plane. Well, we could put it in a plane, or we can do some things with it. That's kind of neat. So I'm going to hide the solid body for a minute. And what I'm going to do is I'm going to fit a plane. So let's go over here. I'm going to go to the plane, turn off that, and I'm going to fit a plane through multiple points. So I'll pick a point here, here, and then down here, okay? So we're going to fit a plane through there. And if you zoom in, you can probably see it's not, this tube is not perfectly in a plane, okay? And now what I'm going to do is turn that plane on. Now I'm going to go into sketch, and I'm going to use just standard sketch mode. And I'm going to pick that plane. Let's hide that other guy there, and let's hide this. Oops. Bring that back. Okay. And then I'm going to now I'm working in a plane. So if I wanted to just, replace this, okay, I'm going to come in here and just draw a line, and I'm purposely just going to go beyond the, the tube itself. And you can kind of see, you'll see it here. You kind of see there's a little bit of a dip in it. So what I'm now doing is making nice, straight, perfect geometry on a plane, okay? So I've used the pipe wizard in this case to get it pretty close and then use it as a guide, okay? But if you zoom in, you can see that it wasn't flat. So if I really want to make this stuff really nice and everything nice and flat and nice tangent radiuses, you could do this on a 2D sketch. And this, of course, assumes that it all lies in a sketch. So now what I've done is I've built a whole new sketch. So let's hide our 3D sketch, and now I have a 2D sketch that's in that plane that's got nice flat segments, that has nice radii, and everything is tangent. And now what I can do is I can run the sweep command, which is essentially what the tube command does. Okay, I'm going to turn this back on because I need the profile from that sketch. But for my path, I'm actually going to pick the 2D sketch. And you can see it'll drive it. And I only went to there. I didn't bother going around the corner. Okay. So now I have a new solid body that's slightly different than the old one. Okay. And it's just cleaned things up and straightened them out. Now, you don't necessarily have to do that. It all just depends. But, you can basically use that 3D sketch. And again, if everything's in a plane, you could then derive a 2D sketch from it and get, a really nice tube that's nice and flat, nice square segments. Okay, so let's go back to our mesh. Okay, and so we've got that one corner. Let's go ahead and just do one more, and I'll show one other thing. So we'll come over here. So it just becomes a repetitive process. We're going to go over to our pipe wizard. We're going to pick our region group. Again, type in our radius. Go to our next step. And we're going to cap the ends. And once again, I don't want to merge it. We are going to rebuild the curve. I'm going to select it. And for this one, maybe 10 points. You don't need a lot. Fewer is actually better because then it's a better chance of being kind of smooth and not so, if you have lots and lots of points, it just kind of causes trouble. Okay. So again, let's hide our mesh, and, we can see we're not quite up there. Now, one thing you can do, instead of going in and editing that curve, another thing you can do is just move faces. So sometimes I'll just grab the face of the tube, and then for the direction, just grab the face again. That'll be normal to it. And you could theoretically just kind of eyeball it up to the center if you wanted to, and then hit OK. Okay. Now, you can see by doing it this way, though, it's not quite centered. In fact, if you kind of highlight over, you can see it's not exactly where it should be. Now, another thing you can do, so that's one thing you got to worry about. Let's go to the sketch itself, and if I double click on it, I can go to the view normal direction. You can actually pick on the circle, and you're going to get a view right down the circle. And you can actually come in and grab this little point here, and I'm going to exaggerate. I'm going to move the circle way over here. So it's going to drive it still down the center point, but you can see we've offset it. So when we do that, when we come up here, you can see it's way off, right? So there's some kind of neat things you can do with this to try to get it to give you the results you want. So actually, we'll just undo that, put it back. Okay, and let's go ahead and double click that again and hide the solid bodies and bring back on the, actually we're going to want that sketch here, and let's bring that in and try to line it up this way. I think this is really the better way to do it, but it's you can kind of play around with it. So now let's so even though it's extruding past it, you can see now we've got a nice intersection there. Let's bring back our surface, and let's go ahead and cut that. We're going to use that surface and then that target, and we're going to pick the side we want to keep, and we're going to get that nice intersection. So let's hide all this other stuff off. Okay. And you can see what we've built so far. Okay. So nice, good intersections, nice segments. Now let's go ahead and mirror over one of these just to see how we're looking. So for example, let's do this. Let's turn off our region groups. It's just easier to see. So as I mentioned, I've set up a mirror plane right down the middle, right there. Okay, because we want to make everything symmetrical. So I can come in here and say mirror. I'll pick this solid body here. This is the symmetry plane here, and I'll mirror it over. And you can see, there's definitely a difference. Now, again, being a hand-built chassis, you would expect this, okay? So if we want everything symmetrical, assuming the car is straight and true, you would definitely you would want to make this all the same way. So that's a mirror copy. The other thing we're going to do, let's hide the mesh for a minute, is mirror this piece over. So I'll come in here, do the mirror command again. This will be the body, the symmetry plane. And then this time I'm going to click trim and merge, and that's going to join it all together right in the middle. Okay. So you can see now we've got that. So that's essentially the process. It's just from this point on, a lot of repetitive work to get it, to get it all done. But when this is done, I'm going to have nice curves, nice bends for the CNC bender, and everything is going to be symmetrical. All right, so let's take a look at our final model. So you can see what it looks like here. Everything matches up. Let's hide the scan data for a minute. We've built the mount plates or boxes that everything mounts up to, but these are all separate segments. So if you look at my solid body, these are all individual pieces, and that's going to be important when I go to export it, to get CNC bent, and then however we're going to machine out where these all match up. Okay, so you don't want it all merged together. So we will export these, and we will probably label them in the software somehow. But we would come in here, we would hit export, we would select the segment, and we'd give it a name. Now, what's key to understand here is when you're doing this, you got I just step parasolid and different formats, where if you're trying to just work with the scan data, you don't have those options. So for example, if I just turn back on the scan data, if you go to output that's just STL. It's not CAD geometry. Plus, it's all incomplete, right? So the reason we build CAD is so we can fix all the mistakes. We can make it correct, the right way. We can mirror it over. Where the scan data is just, points and polygons. You can't really manufacture anything with it. So we basically went from that to this and made everything, nice and symmetrical, and it's all done. And we can review it. And if you have analysis software, you could do some different, FEA analysis, crash analysis, whatever, stress analysis, and actually see how strong your design is before you actually build it. But there's our final design taken from that 3D scan data.
So that wraps up the video on 3D scanning a tube chassis for replication. The idea here was to 3D scan a custom-built chassis or tube chassis and then turn it into CAD so we can replicate it on a CNC bender and a CNC machine. Now, if you'd like to learn more about this process, more about Elevation DF, or how EMS's engineering services can help you, you can reach us at 877-845-2700, or in the description below is a quick contact form you can fill out to reach us. But again, this wraps up the video on 3D scanning a race car tube chassis.